Hi, welcome to more data analysis. This is actually the very beginning of this data analysis unit, so you'll see that it says Notes 1 at the top. Let's just read what I have written here at the top, so follow along. Quantitative data on a single variable is often collected in order to understand how a characteristic of a group differs among the group members or between groups. When we ask a question like, how old is a typical fast food worker? It is helpful to take a survey and then graphically see how the ages differ amongst the group. Our first exercise, we have Charlie's Food Factory currently employs 28 workers whose ages are shown on this dot plot. We're going to answer the following questions based on this plot. First, how many of the workers are 18 years old? And so what you need to do is we need to find 18 on the number line. So here we have 15, 16, 17, 18. So here's 18. Each dot on this dot plot will count for one person. So we have 1, 2, 3, 4. 4 of the workers are 18 years old. Let's go across to B. What is the range of the ages of the workers? Make sure you write this down. Range is equal to the highest number minus the lowest number. Okay. Our highest number, again, we're going to look at each dot represents a person on this dot plot. We have 40, 41. This is 42. So 42 years minus our youngest person is at 16. Even though 16 happens more than once, we'll just do minus 16 years. When we subtract this, we get 26 years is the range from the youngest worker to the oldest. Would you consider this distribution symmetric? Okay, we talked a little bit about this before during class. Sorry, it was just review on the smartboard. But what I have attached, if you kind of flip your packet right over here, is the difference between our different data distributions. We have symmetrical, left skewed, right skewed. Okay? And what you're going to do is you're going to compare what you see here and what we see there. I would not say most of the data is near the center of the range. The center is probably close to 30, and I would say that's not where my data lies. Most of my data lies on the left side. If most of my data lies on the left, it is called right skewed because there's a tail on the right. So let's go ahead and write that down. So this is not symmetric. Okay. Most of the data is on the right. Left, I guess I should get my directions accurate. There we go. Thinking ahead. So we're going to finish by saying it tails off to the right. Thus, and we'll go ahead and call it right skewed. D says the mean, the average rate, can't talk today. The average age for a worker is 22 years old. Why is this average not representative of the typical worker? Let's find 22 on this dot plot. So we have 20, 21, 22. So this is my mean. If this is my mean, the average, okay, I have 1, 2, 3, 4, 5, 6, 7 employees above the average. And then if I count this up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, I have, and you know, even if I didn't include the average, about 20 of the employees below the average. I would not say that this is your typical worker, okay? There are many more workers younger than 22 than older than 22. And let's go ahead and write this down. So many more workers So 20 workers. Then older than 22. And this is where we could say only 7 workers. The other thing that I want to point out, so flip it over to that last page. Right here it says, for symmetrical distributions, mean is the appropriate choice. Talking about typical value for the distribution. For skewed data distributions, remember we have, this is considered right skewed because we don't have a lot of data on the right. The median is a better description of a typical value. Okay? You think about if I have 20 plus 1 plus 7, 28, half of 28. You know, we think about where that data point would be. It's going to be closer to where most of the workers lie. Okay? Let's go ahead and do exercise number 2. A farm is studying the weight of baby chicks after 1 week of growth. They find that the weight in ounces of 20 chicks. The weights are shown below. We're going to construct a dot plot on the axes given. Okay? So you're going to go ahead and do this with me. Where I have the number 2, we're going to go ahead and put a dot plot, and that's what we'll do. And I just cross them out as I go, so I know that I did it, and it kind of keeps me from getting confused. And when it occurs more than once, you just keep going up vertically. The other thing that I want you to notice is I tried to line my dots up horizontally as best I could. So like my first row, they're all kind of similar. Second row of dots, all again very similar horizontally. Now the reason we want to make sure that it's as accurate as possible or looking like our top dot plot as best as possible is so we can take a look at this data and describe the distribution. So if I would describe this distribution, remember we have the choice of symmetric or left skewed or right skewed. How could we describe this? So a reminder that symmetric means that most of our data lies in the center, and this one does. So let's go ahead and call this a symmetric distribution. Okay. And let's move on. The other thing that we're going to talk about besides dot plots are histograms. The following histogram shows the ages of the workers at Charlie's Food Factory, but in a different format. Okay? So the same data that we had on the first page. Letter A, how many workers have ages between 19 and 21 years? So we have between 19 and 21. So using our y-axis to help us figure that out, we have 2, 4, 6, 8, 10. We don't have quite 12, so we'll say 11 workers. What is the disadvantage of a histogram compared to a dot plot? The problem with this one is notice how these numbers are grouped together. So we have a range for our x-axis. So we don't know what any individual data value is. And we'll go ahead and write that down. We don't know what any individual data value is. Okay, again, it is grouped together in ranges. Does the histogram have any advantages over the dot plot? It definitely does. I would say that this is much easier to read than this dot plot. Remember how I had to sit there and count? This is easy to read where I have like 9, 11, 2, and etc. And let's go ahead and write that down, that this one is easier to read. The total amount in each category. Okay, I'm going to stop the video today. We are going to make a histogram together the next time I see you in class. So it'll just be the histogram and then a short homework assignment that goes with it. All right. Hey, thanks so much, guys. I will see you next time.